The fourth rule is the rule for sine and cosine. We'll put those into the same rule. So just sine and cosine. The derivative with respect to x of sine is negative cosine. That's not true. It's positive cosine. That's a weird mental slip. So the derivative of sine is cosine. The derivative of cosine is negative sine. I'll just prove the first. These two proofs are a lot alike. There's not much that separates them. Just one starts with cosine, one starts with sine. So we'll just do the one that starts with sine and ends up with cosine as our proof. And this proof is just kind of a formal proof. It uses the limit definition of the derivative. The downside is that this proof does not explain why it's true. There are a bunch of cool geometric interpretations of this rule. I would recommend checking those out online because they are pretty cool to look at. But for our proof, we're just going to do the one that's based off of limits. So the derivative of sine x is the limit as delta x goes to 0 of f of x plus delta x. So we plug x plus delta x into our function minus f of x, plug x into our function over delta x. We expand this sum using one of the trig identities you guys learned in pre-calculus or algebra 2, wherever you learned it. Sine of x plus delta x is sine of x cosine delta x plus cosine x sine of delta x, and then minus sine of x over delta x. We then group these two terms right here, the sine x cosine delta x and the sine x. We can factor sine x out of those terms. So doing this gives us the limit as delta x goes to 0. Oops, I'm off screen. There we are. Of sine of x, parentheses, cosine delta x minus 1, all over delta x, plus cosine of x times sine of delta x over delta x. So I broke apart this one term as two different fractions. We saw in lecture 1 that this limit gives us 0. And so when we compute the limit, it gives us sine of x times 0, all of which will be 0, plus cosine of x times this term. We also saw in lecture 1, and we spent a good amount of time proving that this term approaches 1 as delta x goes to 0. And so we put that all together to get 0 plus cosine x. The derivative is cosine x. Note that these two results are only valid if your function is in terms of radians. So this rule and that rule are also only valid if you are in radian mode. If you are in degrees, then the rules actually change a little bit. You have a different coefficient in front. So for all of this class, we will always be in radians because these two rules are based off a limit whose proof is only valid if you are in radians. So we are in radians all the way.